Hi everyone, it's me again, and again I'm on my own today. Today I'm going to be talking about how to prepare your teen for iGCSE maths and those key skills in which they will need. It's really common for teens when they are growing up through the high school years. There's certain points where there's a big leap in difficulty, and this can often be felt when you transition from to the iGCSE maths, but also it can happen from iGCSE to A-level maths, or if you're in Scotland, from that 5 maths to higher maths. So these can often be felt as big leaps forward in difficulty. However, there's some things that we can do to help prepare our teens well. We're going to talk today particularly about that iGCSE leap. Um, there are certain concepts that if you have laid a really firm foundation in these, it makes that transition a little bit better. However, before we talk about those concepts, I would also say we've said it so many times that GCSEs are designed to be sat. They're 2 years worth of content with the exam designed to be sat by 16-year-olds. So yes, there's hard concepts and there's different things that you need to just learn, and there's lots of concepts. But there's also an idea of cognitive development. They're designed for a 16-year-old brain to be able to do that. And we hear of children younger that do them and do well in them. But that's not for the majority. The majority of teens will do best if they wait until they're about 16, just for their brains just to naturally develop, and for those processes just to work out. For teens who actually just naturally struggle with maths, it's not their subject. They don't come to it and are able to flourish with it. It just is hard to do. After 16, leave it for the last subject. Even if they're sitting it when they're 18, they're going to have the best opportunity to do well. And for some teens, they even have to wait until they're a wee bit older, 19 or even 20. Um, and that's absolutely fine. This is, we can think, I know teens when they're growing up when they're 16, 17, 18, all those years seem like that's such a long time. They just want to be finished. But when you look back at the span of your own life, you realize that those latter teen years, they flew by. And if they wait a little bit longer, it's going to stand them on really good stead moving forward. Um, that being said, let's go right back to that kind of end of primary school, early secondary. Um, for those that are familiar with the kind of key stage level, that key stage 3 level of maths, and how can we build that up? What to look for in a curriculum that is going to really prepare your teens well for that next stage. Now, I know as a home educator, I've got 7 children. I've got two who are finished and grown up. My eldest is 21, and got everything in between. For my own children, I found that finding a bridge, I found there was lots and lots of really good resources out there for primary age maths. But I actually found it really hard to find a good bridge between primary school and that iGCSE maths. And for and we got there and pulled things together, but I've actually spent a lot of time in this interim period looking for really good, strong, solid material that would prepare a teen for iGCSE. And I think I am a lot closer than I was 5 years ago to finding what is going to do really well after putting my own children and other children through iGCSE now a number of times, and understanding the curriculum really well. What do we need for that kind of key stage 3 prep work? Now, there's certain really core concepts that I think we need to be focusing on to give a strong foundation. The first of these is fractions. So from fractions, to be able to manipulate fractions, you're looking at your understanding of times tables for before key stage 3, so key stage 2, and even key stage 1. So it all kind of builds up. It's like building a building. You put every next layer is built on the foundation before, and if the foundation before is a bit shaky, the higher you go, it becomes more unstable. So a lot of the issues teens have at iGCSE maths, either they're just not quite there developmentally for that jump in subject. They might just not feel confident. The foundational parts might actually be really solid and really well in place. And there's been nothing wrong with the curriculum and nothing wrong with what you've been doing, but it's just they need that extra time to develop. But sometimes there can be parts of that foundation which might have not been fully understood and need to be revisited. Um, or there might be gaps in learning because some things happen, life happens, sickness happens, all these things can just happen and that can create gaps. Fractions, so it can feel when you're working with younger children that whatever curriculum you're using, fractions keep coming up and coming up and coming up. And most younger children, they don't particularly like fractions. I think it can be one of these first abstract ideas that it's hard for them to contextualize and really understand what this looks like. You can understand counting things. You can even understand things like multiplication. You put things into groups, like 3 groups of 4, or and then taking a group of things in division and dividing them up between other groups. That can that makes sense. But this idea of a fraction as a number and linked to that also percentages is a little bit more abstract, and this can be a big sticking point for children, this abstract nature of a fraction as a number. And the iGCSE has an absolute question that is fractions. They have percentages questions as well that are in the paper. But this whole concept of how to manipulate fractions is actually a much more fundamental skill and gets carried beyond iGCSE into A-level and higher maths, where you're having to use the skills of fractions to then manipulate and work with algebraic fractions. And so, but it all comes back to being able to have that really strong foundation. So building that understanding of fractions, equivalent fractions, and improper fractions and mixed numbers, and how to move between all of these ideas. Being able to um, understand when you're doing division, harder division sums with a remainder, how to take that remainder and put that remainder as a fraction. It takes this idea that's something that we often teach fractions in terms of shapes, and I often come back to that when I'm doing iGCSE maths with teens who are struggling with understanding fractions, bring it back really simply. But if you can bridge it over to this idea of the remainder as a fraction, you're taking something that looks kind of geometric, taking a circle and split it into fifths and colouring so many parts that can make it seem geometric, but then taking it back and relating it to number. And that link between something that's visual, but then taking it back down to a number level is really helpful. Now there's some tools that I found really helpful to use. One of them is the FET website, which is I've spoken about it before. It is a website put together by the University of Colorado, and they have lots of simulations. It's great for sciences, but they have a number of math simulations. And this is free to use, which makes it really great. That they have simulations that allow you to look and make those connections of the visual idea of fractions and mixed numbers and improper fractions, and you can see them and you can play with them and you can make them into equivalent fractions. But they take it as in shapes, making shapes and fractions, but then they also can use it as a number line. So you can take that idea of a geometric representation of a fraction and then turning it into something that is much more numerical. So the PhET website, they've got 2 or 3 simulations there which allow you to explore fractions and little games that are linked to them. It's a great resource. Second resource, which is a really good resource, not just for fractions, but for lots of different concepts, is a website called Maths Pad, and I'll put links to both of these down below. Now, Maths Pad is not free; it is paid, but it's actually not too expensive. And if you pay for their package, they've got a wealth of resources and worksheets. But again, they've got little simulations where you can do stuff visually and play with stuff. It's also good for some of the geometry type questions. So both of those websites are really useful for the MathsPad for all maths, but the PhET for fractions and some of the other concepts as well. Secondly, orders of operations. So your BIDMAS, the brackets, indices, division, multiplication, addition, and subtraction. Understanding the order of operations is again a really key idea. Being able to manipulate helps you with the manipulation of expressions, which you then build out into algebra. So working on those order of operations. Linked to fractions is also ratio. So understanding ratio and lots of ratio problems often come as word problems. So word problems in general are often really sticky point questions. So ratio, it allows you to explore deeper mathematical connections in real world problems. So working on those kind of things. The word problems can be also applied to ratio problems as well. With all of these things, I've mentioned with the ratio being making it visual. Word problems and ratio problems, you often get the little story and there's lots of information, and this can just be like, what on earth is this big story? And it's just like, what are they even trying to ask us? Turning these word problems into little pictures can help understand and break down what is being asked. So sketching out the problem, making it visual so that you can that helps you pull out the key pieces of information. It can work with all word problems, but it can also work with ratio. I'll also link down to a sample lesson on ratio in this podcast, where the method that I use for teaching ratio really focuses on this idea of parts. When we have ratio, when you have fractions, sorry, and you split something up into a number of parts, so that would be your denominator number, and then you've got your one whole and all the different parts, and then you're thinking about how many parts of that whole when you're thinking of a fraction. You can use a similar idea when thinking about ratio. And if you really can, if teens can understand, or children can understand that idea of what ratio is, about the how each part of a ratio is, how they relate to each other, that can help with the understanding. So I'll link that sample lesson below. It's easier to see it than for me just to explain it in words. But ratio is another key concept that allows, if they have a firm foundation, understanding what ratio actually is and how these numbers relate to each other, it helps build that foundation for understanding number at higher levels. Next is basic geometry. There's a lot of, in iGCSE maths is a huge chunk of the syllabus is dealt with geometry. So this is things like our circles and our triangles and area and volume, but even simple things like understanding the names of the different shapes and the rules for those shapes. For example, you might have at iGCSE a question where you've got a circle and lots of lines in that circle with different, and those lines form different triangles. If you can identify in that setting, oh, there's an equilateral triangle. You know what an equilateral triangle, you can see triangles, but you know specifically what an equilateral triangle is, and you know what that means. What makes an equilateral triangle different from, say, an isosceles triangle? So these are kind of basic geometry ideas, but when you get to GCSE level, they're all kind of put into one problem. So being able to be happy with identifying shapes, knowing, oh, the equilateral triangle, all the angles are the same, all the lengths are the same. That is different from an isosceles, where two lengths are the same and two angles are the same. You can then take that knowledge and apply it into a much more complex system. But if that basic understanding on the geometry of these shapes is not there, then it's harder when you come to see them in a setting where there's lots of other things happening to be able to zone in on those key concepts. Similarly with area of different shapes and volume, when you go to iGCSE, you're taking these more fundamental ideas and applying them to much more complex problems. So but finding curriculum that really shores up these things that you've probably already done. You've probably in those key stage 3 years, you're doing fractions every year. You're doing something with the order of operations every year, but each one goes a little bit deeper, a little bit deeper. You're building the foundation. Look at those early high school years as a strengthening of the foundation of those key basic principles on which to launch into iGCSE, where you're going to build out and be looking at things with more complex algebra, um, more complex geometry, and that then launches you out into A-level maths. When I've taught A-level and higher math students, you can be doing some really tough maths, and the thing that can trip them up is manipulating a fraction. Um, an order of operation, something, a simple thing. You can be you and a lot of the time it's that you're so focused on the hard maths that the easy maths gets forgotten. But again, it shows that these foundational pieces, they are carried right through up until A level when you're doing some really complex mathematics, but you're still pulling on how to add fractions together and put them into equivalent fractions, and then simplify those equivalent fractions once you've added them together. Stuff that you've done when you're 13 or 14, you're doing when you're 18, and you're doing some hard piece of differential calculus. They all tie in. Those foundational pieces are key to the whole structure of mathematics. So I hope that makes sense. At Arise, we now have a year 2 iGCSE maths. This is perfect for your kind of end of key stage 3, your kind of year 8, year 9 before iGCSE. I hope I've remembered my English years correctly. Right before you would start iGCSE or GCSE maths. And for Scotland, that would be you can S3, S4. A lot of the stuff in this class, the year 2 pre-iGCSE, would be things that would be covered in NAT. It was like NAT 4 level maths for Scottish students. And right before you would be starting to work on iGCSE for English for the rest of the UK. The end of that final bit of Key Stage 3. We'll be using a brand new book, new curriculum that has just been produced by Cambridge, which is a lower secondary school curriculum, which provides an excellent foundation for all these things that you go in to do when you first start the iGCSE. It dovetails absolutely beautifully, and so that it's not so much of a shock when you jump into these harder concepts which come quite quickly, and there's a lot of them once you're doing your iGCSE. So if you're interested in that, I'll link that also below. Thank you so much.